To my colleague, Professor Snyder, who will tell you about K-maps.
A K-map, or a Karnaugh map, is a pictorial method of grouping together expressions with common variables, and therefore eliminating those common variables.
Hello, my name is Professor Mao, and I'm the computer simulation technician here at Project Lead the Way Incorporated, and I am here to talk to you about transistor-transistor logic today and the function of gates. And these little guys right here.
I'm Professor Steppenbeck, and I'm the breadboarding and circuitry technician at Project Lead the Way Incorporated, and I'm here to teach you about breadboarding. This is a typical breadboard that we will use. The first thing you need to do when breadboarding is hook up the power and the ground. The first thing you do is plug the positive bus into the power supply, and then you plug the negative bus into the ground. Now you're ready to make your circuit. Before you can create your circuit, you need to know how the breadboard works. We can show you that by using this LED. To create a complete circuit, you need a power source and a ground. You can just hook the positive side of the LED to the power and the negative side to the ground, and it will light. But you don't want to have to hold it, and that's where the breadboard comes in. So, you'll put the LED in one of these channels, hook up the ground and the power to the buses. Alright, since the negative end is in this channel, you'll hook that to the negative bus. And the positive end is in this channel next to it, so you'll hook that to the positive bus. The electrons are flowing from the power through this red wire into the positive bus through this wire to the positive end of the LED. Then they go out the negative end, which goes to the negative bus and then to the ground, creating a complete circuit. To show you how the breadboard works, these two buses connect all the way down, but they're not connected to each other. So you can move this negative all the way down and it will still light, but if you move it to the bus next to it, the LED won't light. Same goes for this positive bus. You can move it all the way down and the LED will still light, but if you move it next to it, it won't light. Just like the buses are connected horizontally, these channels are connected vertically. So you can move the wire into any of the sockets next to it and the light will still light, but if you move it to the next channel over, the light will not light. Even though these channels are connected vertically, they do not connect over this divot. You can see that when you move the wire and it still lights, but when you move it to the same row across it, it doesn't light. Now that you know how the breadboard is connected, we can make a circuit. We'll start out by making this simple circuit. You can see there's a 5-volt power source connected to each of the 3 switches, and a ground connected to each of the 3 switches. Now the first switch, switch A, or switch 1, goes through a NOT gate. Switch 2 and switch 3 are ANDed together, which is then ORed with NOT switch 1. Now that you've seen the diagram, we'll show you how to make it on the breadboard. The first gate you need to use is your NOT gate. This is 74LS04. You will connect switch 1 to the first input of the NOT gate. Your output will be the second, following your pin diagram. Pin diagrams show you where the inputs and outputs of a gate are. This means that every time switch 1 is switched on and gives an output of 1, whatever this wire is connected to will receive an input of 0. The next gate you will use is the AND gate. This is a 7408. Since switch 2 and switch 3 are ANDed together, you will connect switch 2 to the first input of the AND gate. Then you will connect switch 3 to the second input of the AND gate, and the output will be the third pin. The third gate you will use is the OR gate. Since NOT switch 1 is ORed with NOT switch 2 and NOT switch 3, you will connect the outputs from both the previous gates to the OR gate. Referring to our pin diagrams, we'll see that the OR gate, we need to connect the inputs in the second and the third inputs. And the output goes in the first. The most important thing we need to do is connect each gate to the power and the ground. So the 7th pin will always connect to the ground. And the 14th pin will always connect to the power. Now that the whole circuit is connected, let's see if it works. To see if your circuit is correct, you'll connect the output of the OR gate to the light. According to our simulation, when switch A is off and switch 2 and 3 are on, the light should turn on, which it does. Reset the circuit. You turn all the switches off. When switch B and C are off and switch A is turned on, the light will turn on. This shows that we have wired our circuit correctly. Now you can see how we use all these principles to create a new voting machine, using inputs and outputs and or and NOT gates and breadboarding to create a working machine.